In this chapter, we're going to explore a really critical but often overlooked layer of web security, the application server itself. You know, a lot of the time, developers and security pros are laser-focused on finding bugs in the application's code. But a smart attacker knows that going after the very foundation the application is built on, well, that can be a much more effective strategy.
To really get a handle on this, let's use an analogy that we'll keep coming back to. I want you to imagine your entire web presence as a house. The web application, the part your users actually see and interact with, that's all the furniture, the paint on the walls, the cool appliances inside. But the application server, that's the house's foundation. It's the framework, the support beams. A skilled burglar knows that picking the fancy lock on the front door can be tough. It's often way easier to just walk around the house and check the foundation for a crack you can slip through.
So, in this chapter, we're going to follow a hacker's playbook, step by step. We'll start with the simple stuff, the easy wins and default settings. Then we'll get into the more advanced attacks that exploit deep software flaws and even get around common security tools. And then, most importantly, we'll talk about how you can take all this knowledge and build a digital fortress to defend your own servers.
All right, let's dive into Section 1, Probing for Easy Wins. The very first thing any attacker is going to do is look for what we call low-hanging fruit. We're not talking about super complex zero-day exploits here. We're talking about simple, well-known configuration mistakes that can give an attacker an instant backdoor into the system.
And probably the most common and honestly the most preventable of these mistakes is just not changing the default credentials on admin pages. When you install server software, it often comes with a standard username and password right out of the box, just for setup. Forgetting to change those is like leaving the key to your house under the doormat with a giant neon sign pointing at it.
What's really wild is just how predictable these default logins can be. I mean, take a look at this table. You can see that major servers like Apache Tomcat have historically used super simple, publicly known logins like admin and Tomcat. An attacker doesn't need to be a genius here. They just have to Google a list of known defaults and start trying them.
So this is the typical game plan for an attacker. First, they figure out what kind of server technology you're running. Then they do a port scan, kind of like checking all the doors and windows on a building, looking for an open admin portal, maybe on a common port like 8080. Once they find one, they just start trying all those known default credentials. And only if that fails will they move on to the more noisy, time-consuming stuff like brute force attacks.
Okay, so moving into our second section. After checking for default logins, what's next? Well, the attacker starts looking for another common oversight, leftover default content. This could be anything: sample code, diagnostic scripts, demo apps, stuff that ships with the server but was never, ever meant to be left on a live system.
A perfect example of this is the PHP info page. Now, it's a helpful diagnostic script for developers, but for an attacker, man, it is an absolute goldmine. As you can see here, it just spills all the secrets, the exact server version, every single module that's loaded, and critical file paths on the system. That's everything an attacker needs to plan a much more precise and devastating attack later on.
And here's another one where something totally harmless gets turned into a weapon. This is a default sessions example script from Apache Tomcat. It was just meant to teach developers how user sessions work. But if you leave it on a live server, anyone who finds it can not only see, but actually change a user session data. An attacker could use this to hijack someone's account or even give themselves admin privileges.
Now this slide shows the absolute worst-case scenario. On the left, you see the JBoss JMX console, which is a super powerful administration tool. And on the right, that's an attacker using a common hacking tool called Metasploit to talk to that console. They are literally using the console's own features to upload a malicious file, creating a backdoor. And just like that, they get a full command shell on the server. Game over. They have complete control, all from one simple, forgotten default page.
All right, so once an attacker has picked all that low-hanging fruit, the attack starts to get a lot more sophisticated. Now they're probing for deeper flaws, fundamental weaknesses in the server software itself. These attacks are way more complex because they target the core logic of how the server actually thinks about and processes data. Now, to really get what's going on here, we need to understand two key concepts: encoding and canonicalization. So first, encoding. Think of it like a simple substitution cipher. An attacker can encode a malicious command so it looks like harmless gibberish to a security filter. But once it's past that filter, another part of the server decodes it, revealing the attack. Then there's canonicalization. This is just the process of simplifying data. For example, a server knows that // means go up one directory. An attacker might send a weird version of that, like .%255C, which a filter might not recognize, but the server later on processes it, canonicalizes it back to the standard ./, and the attack works. It's all about exploiting these little moments of miscommunication between different parts of the system.
And what's really fascinating, and frankly a little scary, is how these same types of bugs just keep coming back. This timeline is a great example. You see an encoding-related bug in Apache in 2002, and then boom, 8 years later, a similar bug pops up again. It shows us a really important lesson. Even when a specific vulnerability gets patched, the underlying design flaw can easily be reintroduced years later in a new feature. And you can bet attackers remember this history.
This brings us to a famous piece of advice in the security world: never roll your own crypto. And the reason why is perfectly shown by a classic attack called the .NET padding oracle. This was a huge flaw where a tiny difference in the server's error messages, based on how it handled slightly malformed encrypted data, could be exploited. By carefully sending requests and watching those error messages, an attacker could slowly but surely piece together the entire secret message. It's a perfect example of how a tiny crack can bring the whole wall down.
So, with all these complex threats, a lot of organizations put up an extra layer of defense called a Web Application Firewall, or a WAF. You can think of a WAF as a security guard standing at the front door of your server, checking everyone's ID and inspecting their bags for anything suspicious. But as we're about to see, even these security guards can be tricked.
The biggest weakness of a WAF is that it usually works off a list of known bad things. It's like that security guard has a binder of photos of known troublemakers. A clever attacker can craft a totally new attack that isn't in the binder and just walk right past. For example, the WAF might be programmed to block any request for the famous /sc/password file. But it might not know to block a request for /var/log/syslog, which could be just as juicy for an attacker. And on top of that, attackers can use all those encoding and canonicalization tricks we just talked about to fool the WAF into thinking a request is safe when the server behind it knows it's an attack.
Okay, so this all might sound a bit dire, but it brings us to the most important section: building our fortress. The key takeaway here is that even though attackers are creative, a smart layered defense can make their job incredibly difficult. This process is called server hardening, proactively locking down your server before an attack even happens.
This slide is basically your checklist for building that fortress, and it really boils down to a few core ideas. First, get rid of all that low-hanging fruit. Change every single default password and delete all the sample code and demo apps. Second, you have to shrink the attack surface. That means turning off any features, modules, or protocols you aren't actually using. The less you have running, the less an attacker has to target. And finally, you have to apply the principle of least privilege. This just means the server should run with the absolute minimum permissions it needs to do its job. That way, even if it does get compromised, the damage an attacker can do is seriously limited.
And in the end, this brings us all the way back to our house analogy. You can have the best, most expensive lock on your front door, but that's just an illusion of security if the foundation of your house is crumbling. Of course, securing your application's code is important, but true, deep security means making sure the server it runs on is a hardened fortress. The biggest takeaway from this chapter is that securing your application server isn't just an afterthought. It's the absolute bedrock that all of your other security has to be built upon.